So our group did clean energy. Today we're going to be making the argument that nuclear energy is not only an extremely clean energy source, but also a very reliable and efficient energy source.
Hello everyone. My name is Albert Uziel. I'm an engineering graduate of Rensselaer Polytechnic Institute in Troy, New York. I have worked in the nuclear power industry all my career with companies that provided equipment and services in support of the nuclear power plant's maintenance and outage activities. I'm going to try to answer or make comments on several of the questions that Gia sent me.
Now, what exactly is nuclear energy? I'll tell you. In the early 1970s, war in the Middle East skyrocketed the price of oil. This caused more investors to be willing to invest in nuclear reactors, causing half of the world's nuclear reactors to be built between 1970 and 1985. So a little bit of history there for you, but let's get more into how these things work. Nuclear energy is the use of nuclear reactions to produce electricity. Now, nuclear energy is clean because unlike fossil fuels, nuclear energy actually produces no carbon emissions at all. This is a major upside considering the major downside to fossil fuels was the extreme amount of carbon emissions which caused global warming. Now, nuclear energy is efficient because it produces energy 364 out of 365 days of the year. This is twice as efficient as coal and 3 times more efficient than wind and solar power. Now, all nuclear power plants convert heat into electricity using steam. Plants create this heat through a process called fission. Fission is the process of splitting atoms to create heat. The fission process boils water and creates steam that spins turbines, which produces electricity for all to use.
Nuclear power is the use of nuclear reactions to produce electricity. Presently, the vast majority of electricity from nuclear power is produced by nuclear fission of uranium and plutonium in nuclear power plants. Nuclear power plants are thermal power stations that generate electricity by harnessing the thermal energy released from nuclear fission. A fission nuclear power plant is generally composed of a nuclear reactor, in which the nuclear reactions generating heat take place, a cooling system, which removes the heat from inside the reactor, a steam turbine, which transforms the heat into mechanical energy, and an electric generator, which transforms the mechanical energy into electrical energy.
Nuclear energy is one of our best options moving forward for a clean energy source for several reasons. Energy generation. Nuclear energy generates about 800 kilowatt hours every single year. This saves about 470 million metric tons of carbon every single year, which is equivalent to removing 100 million cars off the road. Reliability. Nuclear energy is also one of the most reliable energy sources as it can run 24 hours, 7 days a week if maintained properly. And to give an example of that, in 2019 within the US, our nuclear plants ran for about 92% of the time. Jobs and economy. Nuclear plants end up supplying about 500,000 jobs in the US, and the average salary is about 30% higher than the local average. Nuclear plants also contribute billions of dollars annually to the economy through state and federal taxes, which can help to keep the economy going. Fuel source and usage. So while it does cost more money to build a nuclear plant over building something like a coal mine or coal refinery, fuel sources actually end up costing much less. As with uranium and thorium and plutonium, they end up costing a lot less to actually use than things like coal. Uranium reserves are also predicted to last much longer than fossil fuels, and that's when we're just speaking about uranium. That's not even mentioning plutonium and thorium. Nuclear energy is also extremely fuel efficient, with nuclear fission producing about 8,000 times more energy than traditional fossil fuels.
Well, nuclear is a zero-emission clean energy source. It generates power through fission, which is the process of splitting uranium atoms to produce energy. The heat released by fission is used to create steam that spins the turbine to generate electricity without the harmful byproducts emitted by fossil fuels. Nuclear energy is perhaps the lowest impact on the environment, including air, land, water, and wildlife, of any energy source, because it produces no harmful greenhouse gases, it isolates its waste from the environment, and requires much less area to produce the same amount of electricity as other sources. Nuclear energy has perhaps the lowest impact on the environment, including air, land, water, and wildlife, of any energy source. It produces no harmful greenhouse effects, isolates its waste from the environment, and it requires less area to produce the same amount of electricity as other sources, as I said before.
Now, let's talk about the negative things about nuclear energy. There are about 9 reasons why we shouldn't use nuclear energy. First, nuclear waste. The waste generated by nuclear reactors remains radioactive for tens to hundreds of thousands of years, and there are no long-term storage solutions for radioactive waste yet.
The radioactive waste in nuclear power plants are of 2 types. One is low-level waste and high-level waste. The first has low radioactivity and includes contaminated items such as clothing, which poses limited threat, and most of the time those are taken away and essentially buried. High-level waste, on the other hand, is mainly the spent fuel from the nuclear reactors, which is very radioactive and must be cooled and then safely disposed or reprocessed. We don't allow reprocessing in the United States by law.
2. Nuclear proliferation. As nuclear fuel and technologies become globally available, the risk of this falling into the wrong hand is increasingly present. 3. National security. Nuclear power plants are a potential target for terrorist operations. An attack could cause major explosions, putting population centers at risk. 4. Accident. The 1986 Chernobyl disaster in Ukraine led to the death of 30 employees in the initial explosion and has had a variety of negative health effects on thousands across Russia and Eastern Europe. Human errors, disasters, terrorists, all can lead to serious problems.
Nuclear power plants are designed with multiple physical barriers that limit the release of radioactive materials to the environment, even in the case of an accident. Now, the first barrier is the fuel itself. It's a ceramic fuel. The second, they're tiny little pellets that are stacked up in a tube. The tube is called cladding, is normally made out of an alloy called zircaloy. That's the second barrier. The third barrier is the reactive vessel itself and the cooling system. The reactive vessel can be something like 6 to 8 inches of steel thick. Now, the final and the fourth barrier is containment building, which is made of a concrete and steel shell. The containment building contained all the releases, and there were really no radioactive releases to the environment at all.
5. Cancer risk. Workers in nuclear industry are also exposed to higher than normal levels of radiation, and as a result are at higher risk of death from cancer.
Now, low-level radiation, which is encountered in the environment, like for instance when you fly, let's say from New York to California, and your plane is at say 30,000-40,000 feet, or for workers in a nuclear power plants that are doing regular routine work. That low level of radiation does not cause the immediate health effects, but it is a minor contributor to our overall cancer risk. Now, on the other hand, exposure to very high level of radiation, let's say as a result of an accident or being directly exposed to a source, can cause acute health effects such as skin burns, nausea, diarrhea, hair loss, vomiting in the short term. And in the acute radiation syndrome, and possibly death in the long term if the doses are really high. It can also result in long-term health effects such as cancer and cardiovascular diseases.
6. Energy production. As a result, much of net energy created would be offset by the energy input required to build and decommission plant and to mine and process uranium ore. It's not worth it. 7. Not enough sites. There aren't enough locations in the world that are safe from drought, flooding, hurricanes, earthquakes, or other potential disasters that could trigger a nuclear accident. 8. Cost. Initial capital cost, fuel, and maintenance costs are much higher for nuclear plants than wind and solar, and nuclear projects tend to suffer cost overruns and construction delays.
The economics are a little more complicated for nuclear power. Nuclear power plants typically have very high capital costs upfront for building the plant. But once they start operating, the fuel costs are very low. The high cost of construction is one of the biggest challenges for nuclear power plants, and they run these days, I'm going to guess, between $6 billion to $8 to $9 billion. So it's a huge investment. Nuclear power has one of the lowest levels of fatalities per unit of energy generated compared to other energy sources. Coal and petroleum, natural gas, hydroelectricity each have caused more fatalities per unit of energy due to air pollution and accidents.
9. Competition with renewables. Financing for renewable energy is already scarce, and increasing nuclear capacity will only add to the competition for funding.
When you compare nuclear versus renewable energy sources, the comparison is a little more fair, I guess you might say. Nuclear power is comparable to, and in some cases lower than, many renewable energy sources in terms of lives lost per unit of electricity delivered. Nuclear reactors also produce much smaller volume of waste, although much more toxic. A nuclear plant also needs to be disassembled and removed, and much of the disassembled nuclear plant needs to be stored as low-level nuclear waste for a few decades. So those are the disadvantages of nuclear versus renewable. On the other hand, though, nuclear power has a very high surface power density, which means much less space is used to produce the same amount of energy, 1,000 times less when compared to wind and solar power. As you can imagine, a nuclear plant can be built in an area of about maybe a third of a square mile, several hundred acres. On the other hand, in order to generate the same amount of power for a wind generation complex, you need probably thousands and thousands of acres, many square miles. And the same thing with solar power. So nuclear is much more efficient in that respect. So right now, the amount of power that generated by nuclear power is essentially equivalent to that compared to that of renewable energy sources. That's everything I was able to put together in the last 2 days since Gia asked me to assemble some data about nuclear power. And I wish you luck with your project, and good luck with your presentation. Take care.
Looking back at what we now know, can nuclear energy be considered clean energy and a serious factor in helping reduce carbon emissions and global warming? Energy is produced through a chemical reaction called nuclear fission, which has no carbon output. There are no interferences or hindrances to energy production, allowing a consistent amount of energy to be supplied. Nuclear power can produce energy 8,000 times more than fossil fuels, providing a greater amount of energy at a much lower cost, environmentally and monetarily. In an article written by the International Atomic Energy Association.org, they said, quote, according to the IEA, the use of nuclear power has reduced carbon dioxide emissions by more than 60 gigatons over the past 50 years, which is almost 2 years' worth of global energy-related emissions, end quote. In regards to accidents, there have only been 3 major nuclear accidents in history: 3 Mile Island in Pennsylvania, Fukushima Daiichi in Japan, and the worst and most famous, Chernobyl in Ukraine. Other than the Chernobyl accident, there were no fatalities with the other meltdowns, and the amount of radiation exposure in these surrounding areas was considerably low, comparable to the amount of exposure from a chest X-ray and a full-body CT scan respectively. As for nuclear waste cannot penetrate the concrete containers in which it is stored once produced. And although extremely toxic, it is produced in such small amounts, quote, an American's entire lifetime of electricity use powered by nuclear energy would produce an amount of long-term waste that fits in a soda can, end quote, from the Wall Street Journal. Nuclear power is safer than many other methods of energy production. It is a cleaner option with 0 greenhouse gas emissions, a more powerful and reliable energy producer, and it takes up a lot less space than other renewable energies. So, in conclusion, nuclear energy should be included in the clean energy transition and be a serious consideration for helping to reduce global warming. Thank you.